Hello guys, welcome back to my YouTube channel. Myself Nikhil, studying computer science engineering and cybersecurity, in which the subject we are going to discuss today is digital design and computer organization, and the topic is concept of K-map and advantages and disadvantages using K-maps. Introduction to K-map. The Karnaugh map or K-map is a graphical representation used in logical design to simplify Boolean expressions. It is a visual tool that helps in identifying and combining adjacent minterms or maxterms to reduce the number of logic gates required for Boolean function. Definition and purpose of K-map. A K-map is a graphical representation of a Boolean function's truth table. It maps each minterm or maxterm to a unique cell on a grid, where each cell represents a specific combination of input variables. The purpose: K-maps simplifies Boolean expression by identifying adjacent minterms or maxterms that can be combined into larger groups, leading to more efficient logic implementation. Advantages of using K-maps. K-maps offer several advantages in logic design, particularly for simplifying Boolean function. First, simplified logic. K-maps enables the identification of adjacent minterms or maxterms, which allows for the simplification of Boolean expression and the reduction of number of logic gates required. Second, visualization. The graphical representation of K-maps provides a visual aid for simplifying Boolean expressions, making the process more intuitive and less prone to errors. Third, minimized implementation. Simplifying Boolean expression using K-maps result in more efficient and cost-effective implementation of logic circuits, as fewer logic gates are required. Disadvantages of using K-maps. While K-maps are a powerful tool for simplifying Boolean functions, they also have certain limitations. First, limited number of variables. K-maps become increasingly complex and unwieldy as the number of input variables increases. Beyond a certain point, their effectiveness decreases. Second, complexity for multiple outputs. K-maps are best suited for simplifying Boolean expressions with a single output. When dealing with functions with multiple outputs, the process becomes more challenging. Constructing a K-map. Constructing a K-map involves understanding the grid layout and mapping the truth table entries in specific cells. Determine the grid size. The grid size of the K-map is determined by the number of input variables. A K-map with n variables will have 2 power n cells. For example, the n value is 2. The number of variables is 2 variables. Then the input variables in the grid will be 4. Second, label the rows and columns. The rows and columns are labeled with binary combination of the input variables. The order of the labels is chosen in a gray code sequence to ensure the adjacent cell differ in only one variable. Third, map the truth table. Each minterm or maxterm for the truth table is mapped to its corresponding cell on the K-map. The value of the output variable for the minterm or maxterm is placed in the cell. Simplifying Boolean expressions using K-map. Simplifying Boolean expressions using K-maps involves identifying and grouping adjacent cells that contain ones for minterm or zeros for maxterm. First, Group adjacent cells. Identify and group together adjacent cells that contain ones or zeros. These groups should be as large as possible while remaining rectangular or square or single also. Second, formulate Boolean expressions. For each group, identify the input variables that remain constant with the group. The product of these variables along with their complements, if applicable, represents the simplified Boolean expression. Third, combine grouped expression. Combine the simplified expression for each group using the OR operation. This results in the overall simplified Boolean expression for the function. Conclusion and summary. K-maps are a valuable tool for simplifying Boolean expression in logic design, offering advantages in terms of efficiency and implementation. Advantages: simplified logic, visualization, minimized implementation. Disadvantages: limited number of variables, complexity of multiple inputs. Thank you for watching. Please like, share and subscribe.